My name is Chris Canfield. I am the outside sales rep for most of the western part of the country. Soligent is one of my accounts. I obviously work at Outback. Mark Mays, who will take over the presentation in about 15 minutes, is our chief application engineer, and he will be the one that will speak more specifically on the main topic of this presentation, which is AC coupling. And sorry, the first slide is always the toughest to get going. There we go. Here is the overview of today's presentation. I'm going to cover the first 3 bullets, just really an overview for me, just an overview on our existing products, our existing inverter charger solutions. That'll be the Radian and the Skybox. Would like to talk about what a system edge package is. As for installers, it's probably the easiest way to source an entire system from Outback. What UL 9540 means, as that is something that is up and coming. It's already existing in California, and as we know, a lot of the solar regulations that start in California will then branch their way east and or west to Hawaii. And then Mark will take it over and we'll talk about AC versus DC coupling, which again is the bulk of this presentation. First of all, I just wanted to touch on what most of you, if not all of you on this call already know, on this webinar already know. There has been recently, really the last year and a half, maybe 2 years, a huge increased demand for solar storage. And why is that? Many reasons. Time of use or peak rate. The example I always use is San Diego Gas and Electric has a peak rate between 5 p.m. and 10 p.m. Of course, that's when everyone's using the most power in their homes. And having batteries is really the only way to knock that peak down and not get charged that entire rate, the high rate during that entire 5 to 10 p.m. time. Backup power for both planned and unplanned outages. Anyone in California, this is near and dear to your hearts, especially if you're in PG&E territory where the utility will often shut things down in advance of a wind event, due to what happened, the Paradise Fire a couple of years ago and the lawsuits that followed and the ensuing bankruptcy. To be as safe as possible, they will shut the power down in advance of those weather events. And as we learned last year, sometimes that can be for 4 or 5 days at a time. Obviously, if you have storage, solar, I should say, with no battery, you have no grid, you have no solar. A lot of people learned that the hard way last year during these shutdowns. So adding storage, which again is AC coupling to an existing grid-tied system, is something that we do a lot here at Outback. We help customers and installers with a lot. And again, that will be what Mark will talk about in a little bit. And of course, adding storage can shorten payback time. The reason I have the asterisk there, for example, is I live in Nevada, very low, totally flat utility rates where storage, quite honestly, does not make sense if you're tied to the grid. But in a lot more places, daily, it seems like in more utilities realms, it does indeed shorten the payback time. Again, whether it's due to time of use or outages or what have you. Why add storage to an existing grid-tied system? Well, similar to what I just said, but in addition to adding it for shutdowns, for utility shutdowns, there's reduced origination costs for installers. You already have those customers, as an installer, I always like to say, where the bodies are buried. So you can call on those folks that have an existing system and ask them to, if they'd be interested in upgrading to storage or adding storage. If you are someone that does install storage solutions, but there are other installers in your area that do not, and this happens a lot, you can get referrals from those folks that have grid-tied customers wanting to add storage. And that's what that third bullet is there, from referrals from installers who don't do batteries. Mark can talk more about this next section when we get to him. But as far as no more guesswork, we have a relatively, well, it's actually very easy to use sizing tool to help you size out the system to be added to the grid-tied system. We have packages with very few external connections. We have a single SKU actually for our AC coupled packaging. That's more for the distributor, but nonetheless, that also makes it easy for the installer to order too. And pre-programmed configuration files that make the whole thing work. EnerSys and Outback, just to touch on that a little bit, you know, Outback's been around for 20 years. EnerSys, which is our parent company and has been for nearly 2 years, is a battery manufacturer that's been around for 100 years. Our products are tried and true. They've been out there for a long time. So without further ado, let's get into those products. I'm just going to touch again on the Radian and the Skybox. Most of you hopefully are familiar with what those two products are, but again, just a little bit of an overview for you, as these two products are the bread and butter as far as inverter chargers go, of what we sell and help customers with at Outback. Here's a typical grid tie system. You know, PV goes to the inverter, inverter takes that DC, turns it into AC, spits it out to the grid through the, of course, the main panel and the meter. Very simple, straightforward. A Radian system, which is a storage system, is a little more complicated in that the PV, the DC from the PV, has to first go through what's called a charge controller. Charge controller is basically a step-down DC to DC transformer. This charge controller picture, the FM100 or FlexMax 100, takes 300 volt strings. So 300 volts in, and then it gets, sent down to battery voltage, which in our case with the Radian is always a 48 volt battery. So 300 volts in, 48 volts out to the battery. Then we hit the inverter charger. You have your sub panel or your critical load panel here. And the Radian can also in grid tied mode do what a grid tied inverter does. And that is feed excess to the grid through the main panel. The Radian AC input modes. This slide here starts a whole presentation, but that's not today's presentation. So I just want to touch on this a little bit and let everyone know how versatile the Radian is. And by the way, the photo over here, you see there's a Radian, you see there are two charge controllers. This piece of equipment here, I hope you guys can see my cursor. This piece of equipment between the charge controllers is called the mate. It is the needed communication piece for a Radian system. And this over here, which is on the side of the load center, is called the hub, and that ties everything together communication-wise. So you see this is all pre-mounted on a board. We call this the Flex Power Radian. We sell Flex Powers with other flavors of inverters too, some of our smaller off-grid inverters or just some of our smaller inverters, but the Flex Power Radian is where you can have everything pre-packaged, pre-wired, and pre-mounted on this board for you. To try to make it as easy as possible for you to install the product. So if you hear me say Flex Power, this is what I'm talking about. This is the Flex Power Radian here. This is the Radian in the load center, the charge controllers, again, in the communication equipment. Multiple modes. By now, I'm sure you've all read and memorized them. Everyone will get this presentation afterwards in PDF form, so you'll be able to look this up. But just suffice it to say from this slide, the Radian is super versatile, whether it's in grid tied mode or one of the other modes where you're trying to basically isolate yourself from the grid. Radian is an excellent choice. The one mode I did want to touch on specifically as to how it works is the grid tied mode. It is the only mode that exports to the grid. Everything else tries to draw primarily, if not only, from the PV and the batteries. This one, in this mode, the Radian will basically act as a grid-tied inverter when the critical load panel is being properly powered and the batteries are fully charged. Excess will sell to the grid. So I would say that about half the systems we sell with the Radian are tied to the grid. The other half are off-grid. Not everyone that's tied to the grid, of course, is in grid-tied mode, but it is about 50-50 the amount of Radians or Flex Power Radians that we sell that are grid-tied or are completely off-grid. The Radian is, of course, an off-grid inverter as well. So fishing cabin, something out in the middle of nowhere where there's no grid, the Radian, you saw just this right side of the equation just basically disappears, and the Radian will power the loads at that off-grid location. Radian comes in an 8 and a 4 kilowatt inverter size and can work with multiple charge controllers, not just the FM100, which we do have pictured. Although the FM100 has become our best seller, it still works, of course, with our existing FM80s and FM60s, although those charge controllers only take 150 volt strings. So we've been selling a lot more FM100s, and that it cuts down on the balance of system cost. The next version of inverter charger, or the newest version of inverter charger that we have here at Outback, is called the Skybox. The Skybox, I just want to go back to this Flex Power Radian. Again, charge controllers, communication equipment, inverter charger, all pre-mounted on a board. The Skybox basically has all of that capability in a single housing, in a single box, which you're looking at right here. Comes with the load center, but the Skybox itself, I'll get into the specs, but it's a 5 kW unit that has all that capability without needing any of the external charge controllers or communication equipment. It is a transformer-less inverter charger. It is 5 kilowatts again, but it's real nice and slick and very simple to install. Can be used off-grid, but we really don't recommend it because it's transformer-less and therefore doesn't have any surge capability. But it's a really nice, slick evolution of what Outback has always had, and putting everything into a single housing to make it simple. And it also does AC couple. Both the Radian and the Skybox do AC couple. Mark will talk about that again in just a few minutes when I'm done here. One thing that's cool that the Skybox has evolved further than the Radian. The Radian, by the way, has been around for over 10 years. So firmware has been upgraded, of course, and there have been improvements made over that course, but the basic functionality of the Radian is the same as it's been for 10 years. You don't have a lot of inverters that last in the market for 10 years, and the reason the Radian has is because it's such a good product. It's our workhorse. A lot of people swear by it. It's our biggest seller by far. The Skybox at some point will probably be our biggest seller, but it's still relatively new and people are getting used to installing it. One thing that's cool about the Skybox is the simplicity of programming it to save the customer money. The inputs I have down here, rate schedule, and that can be variable like San Diego Gas and Electric. That can be flat like, you know, most other places in the country. The allowable amount of export, the battery replacement cost, basically the cost of the battery bank, and the reserve battery percentage, which basically means the depth of discharge of that battery bank. The Skybox has an advantage over the Radian in this programming. The batteries that the Skybox will work with can be either lead acid, which of course is, you know, traditional, or it can be lithium ion, and the depth of discharge changes. We recommend a 50% depth of discharge with lead acid batteries. With lithium ion batteries, for example, Simplify batteries, you can discharge 85%. So with those four things, those four little things programmed into the Skybox, which you do right on the Skybox itself, when you're setting it up, or the installer would do that when he or she is setting it up. The Skybox will automatically draw from the lowest cost source of energy. During the day, of course, that's going to be the PV, right? Then maybe in San Diego, that 5 to 10 p.m., that's where it's going to draw from the battery, you know, if that's peak time. Again, you program it, and the Skybox on the fly determines the lowest cost source of energy and will draw from it. So it saves customers money really no matter what application or what subset of application the Skybox is being used for. And again, here's a slide that kicks off an entire presentation. I don't want to get too much into it, but just net metering with battery backup, self-consumption, non-export or maximum independence, anything that you want the Skybox to do with those four little inputs, the Skybox will pretty much take over for you and will determine that lowest cost source of energy for you, saving the customer the optimum amount of money at all times. Just a quick side-by-side, I mentioned that the Skybox is either that the Radian is either a 4 or an 8 kVA unit. The Skybox is a 5 kVA unit. Surge power. So the Radian is officially rated at 2x its 2 times its nameplate for surge. Anecdotally, it can surge higher even than that, you know, because of the transformer that it has on board. Whereas the Skybox has no extra surge capability because it has no transformer on board. If there is a surge of over 5 kVA, it would knock the Skybox offline and you would have to wait the 300 seconds to 5 minutes for it to fire back up. So that is a pretty significant difference between the two. The time of use support, I just mentioned that it's advanced with the Skybox. It is basic, it is there, but it is more basic with the Radian. It can be programmed for that, but not as smoothly, not as nicely, if you will, as the Skybox can. Self-consumption, the Skybox with the external CTs can back up the whole house. The Skybox is also outdoor rated. The Skybox takes two 600-volt strings, which Mark will talk about this a little bit, but makes it a nice drop-in for someone that wants to add storage and maybe has an old 5 kW Fronius IG on their house, because you already have the 600-volt strings there running down to that particular inverter. If it's out of warranty or not working properly and they want to add storage, you can drop the Skybox right into that because it takes 600-volt strings. Whereas the Flex Power Radian with these charge controllers, they take 300-volt strings. But each of these charge controllers can take 7 kilowatts worth of PV. This is actually a little outdated. It says 6 or 12. It actually should say 7 or 14 kilowatts of PV, because each charge controller can take up to 7 kW of PV. Off-grid, like I said, the Radian for sure. The Skybox, it's not recommended. If someone's going to go off-grid with Outback equipment, we definitely recommend the Radian. AC coupling, and again, these last two I will let Mark talk about in his presentation, which I believe starts right after this slide. But they both can support a 7.6 kilowatt grid-tied inverter. Even though this one is only 5 kilowatts, that does limit the power, they both can support 7.6 kilowatts of grid-tied inverter. Now, the caveat with the Skybox is it needs to be a 7.6 kilowatt inverter that is UL 1741 SA compliant. If it's an older inverter, then the Skybox can only support a 5 kVA grid-tied inverter. So again, Mark will touch a little more on that. And I'm going to really go over this quickly. System Edge. System Edge is everything, all in one. If you want everything soup to nuts in your storage system, we sell what are called System Edge pre-bundled packages, which is a Flex Power Radian or a Skybox. The rapid shutdown, we do sell the IMO Fire Raptor, which is the module level rapid shutdown device that's needed. And it's the only one that we sell. But we do sell it directly. We don't even white label it. We just buy it and sell it. We're basically a distributor for IMO, and we package it up with our System Edge packages. You get all the communication that's needed, whether it's a Flex Power Radian or a Skybox, and you can get the battery along with it. The battery in this particular instance is a Simplify battery, but you can get all sorts of lead acid batteries as well. We sell about a dozen to 15 different System Edge packages. But the nice thing is, for the distributor, it's a single SKU. So if they can find that one SKU that fits the system you're looking for, it's an easy order for us. Again, at Outback, we're all about trying to make it as easy as possible to get our equipment out there. We fully recognize that our equipment is not as simple as grid-tied equipment, and I really think that we've done a good job in doing that. So UL 9540, I'm going to be real brief on this, briefer than I even thought I would be. That's basically a UL certification for a system, like this System Edge package that you see back on this slide. So it's a combination of a UL certified battery pack and a UL certified inverter. It's coming, it's already there in California. You see this first bullet here. In 2018, late 2018, I think there was a building code adopted where for a system, it needs to be UL 9540 certified. I don't believe that it is 100% being adhered to. And the reason I say that is we sell a lot of non-UL 9540 systems into California with, other batteries that haven't been certified. But, it's coming, right? It's there. I think it's sitting there. I think at some point that it's going to be a hard requirement. It isn't yet, but Outback is, ahead of the game in that we have this particular System Edge package, UL 9540 certified. And that is a combination of either a Skybox or a Radian our IBR, which is our integrated battery rack with either 3 shelves or 2 shelves, and Simplify batteries. As of right now, the only packages that we have are these 4: Skybox with the IBR3, Skybox with the IBR2, and the FlexPower Radian with either the 3-stack or 2-stack. Those are the only ones that we have currently UL 9540 certified. I believe we're working on getting more certified, more batteries, basically. These are the 2 pieces of equipment that are already certified. We're getting more batteries certified into this package. Our batteries are all UL certified. It's just not as part of this 9540 package. Bit of an extra hoop to jump through, but again, Outback being ahead of the game, we have jumped through it with this particular package. And with that, I will turn it over to our Chief, again, Application Engineer, Mark Mays. Jamie, do you have any questions that have come up?
Excellent. Yeah, let's see if we have any questions before we move forward into the second half of this presentation. So feel free, submit comments, questions in the chat box or the Q&A poll here.
I went to high school with a John Klein. I just saw that name pop up.
Mark's been doing a good job of answering the incoming questions too, so I think that we don't have anything looming.
Perfectly fine. That's cool. I'm not following that, of course. I'm just looking at the presentation. So, Mark, whenever you are ready to steal the screen from me and the microphone, please go ahead.
Okay, so hopefully everybody can hear me okay. And welcome to the AC versus DC coupling part of our presentation today. And I wanted to just add a couple of things about the System Edge package. We have been coming up with sizing tools and things for a number of years with Outback, and then when we came up with the System Edge packages, we wanted to make it even easier for people to make sure that they got their designs right. Because I've been an applications engineer with Outback for almost 10 years now, and it's kind of, people come to know it as Mark's 90% rule. So 90% of the problems that I see fall into one of 3 categories. Either it's a design issue, it's a sizing issue, or a configuration issue. And the System Edge packages address all those issues. And it's one of those things, especially I know people that have transitioned from grid-dependent inverters into storage-based inverters. Some of those design, configuration, sizing issues can be a bit challenging. So with this tool, which I'm going to demonstrate at the end, after I do the AC and DC coupling portion, you're going to see we've made it really easy. The design portion, you're just sizing up the loads with the storage, and then we come up with the System Edge package, and then we do the sizing portion and string sizing at the end of that, at the very end of the sizing tool. And then we have configuration files that you can download from our website that match up with your System Edge package. Because once we know the inverter, the solar charger, the batteries, then we know what the configuration should be. So there might be a few things, like if you're going to add a generator, you might have to do some generator programming or whatever, but 90% or more of the configurations are downloadable. So we basically taken care of Mark's 90% rule with the system sizing tool. So we'll show that later, and hopefully you'll find that useful. Okay, so just to review, a typical DC coupled system. When we say DC coupled,
hey, Mark, sorry, this is Chris. I don't know if you're sharing your screen, just because I've got the green bar that says I am still sharing my screen.
How's that?
There you go. That's it. Thanks, sir.
Okay. So so this is a typical DC coupled system, and this charge controller is how we are getting the energy to the batteries and to the inverter, right? So we're showing it as kind of a series thing, but really the inverter, the batteries, and the charge controller are all in parallel, right? So what we are doing is just saying, we say DC coupled, It's how we get this to, you know, the inverter and out to here. So, so it's DC coupled. So this is all DC. And inside the grid tie inverter, or grid dependent inverter, they have a DC to DC converter. It's just not a separate component. It's just inside the inverter. So when we go to an AC coupled system, basically we're putting the inverter in series with the grid dependent inverter. So we have the DC coming in, have the DC to DC converter, and then we have the DC to AC inverter inside. So we have AC power coming out, right? And that goes into our inverter. And when we're grid connected, we have a transfer relay inside that closes between the output, this is the output, and the input. So we're just like a piece of copper wire. Now, the other thing that we did add is we have a backup load panel here, our critical loads panel. So we moved some of the circuits off the main panel over to the backup load panel. But other than that, we just in series, this is like when we're grid connected, it's what I call copper wire mode. We're just like a piece of copper wire. We're no different than it was before. The grid tie inverter is still powering the loads. We've moved some of them over here, but it's just basically operating like it was before. We put our inverter in series, okay? And then of course we have the batteries. So when we're grid connected, it's just self-consuming. Whatever energy is produced on the backup loads panel goes to the inverter. It gets self-consumed here. If there's anything left over, then it goes on out to the grid. No different than normal operation than what the grid dependent inverter was doing before. Okay? So, but before we get to AC coupling, you might want to explore an alternative, retrofitting the system in a DC coupled way. So with Skybox, it's a pretty easy conversion, as Chris mentioned earlier. We have a 600 volt input. You can take strings of like 9 to 13 modules, and you can move those directly into the Skybox inputs. Let's go back to this previous stage. So we have two inputs here. They're actually in parallel. So you could just put like a single string here. You can have up to 6,500 watts connected watts. Now Skybox is only going to convert 5,000 of that, but you can have 6,500 watts, because most arrays are only going to run about 75% efficiency max anyway. So, but you could hook up two strings, but they would be in parallel and a single MPPT. Okay, so this could be a good way to go. You know, you can do like one of our installers. They'd add the blue LEDs. That's good for another 10 or 20% of the sticker price, right? And the rapid shutdown requirements still apply. Now, another thing you could do, you could, if you had like a big system, you know, you could just pull, you know, 1 or 2 strings over Skybox and just leave the rest of them connected like they were before. And whatever rapid shutdown requirements you had before would still apply. Although it could, you know, you might want to check with your local authority having jurisdiction and find out whether or not they would make you come up to the latest code cycle or not. So you can also do this with the Radian, but as Chris mentioned earlier, these are 300 volt charge controllers. So you might have to take that 600 volt string and, you know, cut it in half and put, you know, half of it to one charge controller and half to the other. Okay, so it gets a little bit more complicated with the Radian. But we'll talk a little bit more about the trade-offs between AC and DC coupling. I think in the long run, I think DC coupling, if you can go that route, especially on a new system, I would always recommend DC coupling for a new system. I would not design an AC coupled system from the get-go. You might think, oh, well, the grid-dependent inverter has better efficiencies. But where we have storage, you have to keep in mind you're gonna lose 15% of that energy when you're charging the batteries. So, you know, all those gains that you think you're having kind of go away when you're charging batteries. Okay, so The other retrofit option, obviously, is going to be AC coupling. So let's talk about AC coupling a little bit. So again, just kind of reviewing, the grid-dependent inverter. A lot of people, buy a grid-dependent inverter not realizing that when they're no longer synchronized to the utility, then the inverter shuts off. That's kind of been a surprise for a lot of people. I've talked to a lot of those customers that said, hey, they said I'd always have power. So the grid does provide that synchronization, and there's no ability to store energy for off-sun hours. So that's kind of like the big obvious shortcoming of an independent inverter. Okay, so again, we're showing that, as I showed earlier, we're inserting our inverter in series with the storage here. And one of the things that we do, even though I said we're kind of in copper wire mode here, we can, when the battery needs to be topped off, we can top that off with renewable energy. So it is coming from the renewable energy over here to keep the battery charged. Okay, and then at the end of the day, when the sun goes down, then what happens is rather than exporting utility out the direction like in the previous slide, now the energy is going to come back in from the utility, and it's going to power the main service panel as well as the backup load panel. And however, with Skybox, because it has some intelligent energy management capability, it has an external CT here, so it could actually take some of that stored energy and offset some of the load. And you can put a setting here called min SOC that says, okay, I'm just going to take the top maybe 20% off my battery to kind of self-consume some of the energy I've produced during the day. And it'll make sure it never exports any past this point, past the main service plan with this external CT. But again, this is when you're grid connected. Okay, and this is one of the things I think people new to AC coupling get confused is this is all grid connected. Okay, this is the behavior of our standard inverter when it's grid connected. Now, when you lose the grid, now our inverter, the battery-based storage inverter, becomes the new grid source for the grid-dependent inverter to synchronize to. So we provide that synchronization that the grid used to provide. Okay. So what happens is the grid-dependent inverter is satisfying all this load. If there's any shortfall of that, then we will also be pulling energy from our battery, and in parallel with the grid-dependent inverter, we will help satisfy that load demand. Now, if the grid-dependent inverter is producing more energy than what's over here on the backed up load panel, then that extra energy will come backwards, if you will, because we're thinking that we're in inverting mode. It comes back in an unregulated charge onto the batteries because we're regulating voltage at this point, not current. Okay, so it comes back, and that's why we have these some protections that I'm going to talk about here. Protect the battery from being overcharged. Okay, and then the final thing with grid loss, and then when the power, when the sun goes down in the evening, then power is coming solely from the inverter. We're taking energy from the battery to power the loads until the next day when the sun comes out, and then the cycle repeats. And this cycle will continue to repeat until we get the grid to come back online. Okay, so it's going to go from here to this and this. It's going to switch back and forth like this during that time. Now, one of the things that I also want to point out is we don't recommend full-time AC coupling. We've seen people try and do this in off-grid systems, where they want to AC couple every day. And the reason we don't recommend that is that when the battery charging that takes place, in this scenario, when there's surplus energy and it comes back onto the battery, it comes back in an unregulated charge. I mean, we make sure the voltage doesn't go too high. We make sure the current doesn't go too high, but still it can fall down, and you know, it's just unregulated. The voltage and current can both be highly variable, and which is not the optimum way to charge a battery. So if you're just going to, you know, have emergency backup power to get you through a week or two of the, you know, the public safety power shutdown in California or hurricane or wherever it is that you live, that you know, you have some grid outages periodically, that's really what this is intended for. And so doing full-time AC coupling, just know that that's going to cut some life off your batteries from normal operation and regulated charging. So keep that in mind. Okay, so the Radian, it uses a frequency shift technique. We used to use something called a blackout relay to protect the battery. If too much charge was coming from the grid-dependent inverter, we just cut off the connection. So now we use a technique called frequency shift. So to get this to work, we have some downloadable firmware from our Outback website. So you're going to download that firmware, load it onto the Radian inverter using our system controller, our Mate3 system controller. And what it's going to do, you program it just the same way you normally would with the battery voltage, current limit, and you know, for how much time. And then when the battery voltage, should it exceed the active charging voltage by more than 0.4 volts, so the absorb, the float, or the cell RE, depending on which one of these targets is active, it's going to start increasing the frequency. And if on the older UL 1741 or IEEE 1547 inverters at 60.5, they'll just shut down, go offline. And then the Radian inverter will power the loads until the batteries go down, and then the grid tie inverter will come back on. They'll start powering the backup load panel along with Radian, or if there's extra energy, it's going to come back on and charge the batteries again. And if the batteries get too high, then we protect it. One thing that is, I believe, unique about the Outback system versus at least some of our competitors is that the AC charge current exceeds the AC charge current limit setting. We will also increase the frequency shift. Now, we will continue to increase frequency past the 60.5. And if you have a UL 1741 SA, that's the supplemental addendum to 1741, that hasn't turned into an IEEE spec like UL 1741 turned into IEEE 1547, there will be a forthcoming IEEE standard. But right now, there's California Rule 21. There's actually at least 2, if not 3 flavors of that. And then Hawaii has their HECO, the Hawaii Electric Company, has Rule 14. And so they have these grid support conditions that allow the grid to be supported. After all these years, utilities saying, no, you can't connect to our precious grid. You have to synchronize for 5 minutes and then maybe we'll let you connect and all this. So now they're saying, well, gee, you know, there's the solar density is such that you know, all these solar systems out there could actually help support the grid. So one of the support functions they have is something called frequency watt. So if there's too much energy on the grid, the utility can actually increase the frequency and get all these grid-dependent inverters, which are about 90% of the solar generation out that don't have storage. That's also an opportunity for you guys, I guess, to add storage. And then they'll increase that frequency. So we do kind of the same thing. So when we start increasing the frequency, a UL 1741 SA set up for Rule 21, and you have to do this. You have to go in your grid-dependent inverter and set it up for Rule 21. Make sure you set it up for the one that has the frequency that goes up to 62 hertz, not 60.5, but go in there and set it up for that. And as we shift the frequency up, the grid-dependent inverter starts lowering its output. And I should have queued up a video. I have a video that's showing you how it works. But it goes like between about, like say the target was 54 volts. It'll go between about 50 and 54 volts. It'll kind of slowly go up and down during that range. So it's not going to over voltage the batteries, but it's not giving a constant voltage either, which would be the ideal situation. But it's not going to completely trash your batteries with over voltages. It's very fast responding. So it's kind of a quasi, regulation on your batteries, but it's not going to harm them with over voltage or over current. It's just not the most optimal way to charge your batteries. And for a couple weeks out of the year, it shouldn't be a problem. Okay, Skybox also uses a frequency shift technique. It can do 5 kW power. So on the older grid tie inverters, the non-SA grid-dependent inverters, you can go up to 5 kW. But there's a lot of these 7.6 kWs out there. And if it's a 7.6 kW UL 1741 SA version, I think that came out in like 2017 or so. So if it's something that's come out in the last few years, then Skybox, if it starts putting power above this 5 kW, it'll use that frequency watt function of California Rule 21 or HECO Rule 14. I think the California Rule 21 62 hertz version works the best from the testing I've done. So even if you are not in California, you can still use, you can still put the grid-dependent inverter in that mode, so it will respond to the frequency watt function. And you'll need to check with your local utility to make sure they're cool with that, but I can't imagine why they wouldn't be. And then there's the optional external CT. So when you are grid connected, when you're not in off-grid mode, you can still use some of the time of use and self-consumption functions of that. And one of the things that's unique also, I did some testing using a SMA inverter, the UL1741 SA compliant, and we've had both AC and DC coupled solar going to it. And it's kind of interesting when it's in the off-grid mode where we're acting like the grid source to the grid-dependent inverter. It takes that AC coupling power, and when we reduce the load down, it would start curtailing the DC coupled first, and before it would start curtailing the AC coupled portion of it. And it worked really slick. I wouldn't recommend doing this with the Radian, because the charge controller, the DC-DC converter, it works independently of the Radian. It's not coordinated. So I would not recommend AC and DC coupling with the Radian. But for the Skybox, it's not a problem. And in terms of generator support, with the Radian, we recommend a load. We still have 50 amp double pole relay we recommend. So whenever the generator comes on, it will automatically disconnect the grid-dependent inverter. With Skybox, if it senses any current going the wrong direction, like going out the generator port instead of in, then it will just disconnect it. So it's a much simpler. There's no additional hardware required for the Skybox. One limitation, though, is that there's only a single Skybox inverter for AC coupling applications, so you cannot stack the Skyboxes. So one inverter is the maximum you can do with Skybox. And with the Radian, we will support up to 3. I know people have done 4 or even more, I believe. Radians in parallel, just make sure that they're all set to be on all the time. So don't use the power saving mode when you do that. Okay, so the pre-bundled systems, here's that grid tie relay. Here's a 30 amp disconnect you can put in there, because a lot of times the grid dependent inverter is outside You might want to disconnect that inverter for whatever reason when you're trying to troubleshoot the Radian or something, if there's an issue. And then this grid tie relay that can mount externally, if you like. And then it comes with an 8.3S system controller and display. Skybox, everything you need for AC coupling is in Skybox already. Don't need anything special. So if we do a side-by-side comparison, continuous power, we can do 7.6 kW. There's a lot of those grid-dependent inverters out there. That limit is 5 kW with Skybox, unless it's a EL 1741 SA, where we can employ the frequency watt function to keep anything over 5 kW backed off. Maximum battery charge power, 7.6 versus 5 kW. That's in the off-grid mode. They both use frequency shift. They both protect the batteries with voltage and current protection, frequency watt curtailing, time of use without grid charging. Excuse me, if you live in California, this could be really important because I know SGIP and some other utilities and programs have a requirement that you cannot charge batteries from the grid. With the Radian, we can kind of bias it that way, but we can never promise that you'll never charge batteries from the grid when we use our grid use timers. But with Skybox, we can guarantee that it will never charge from the grid. AC and DC coupling, stackability up to 3 with Radian. Excuse me. Single inverter with Skybox. AC and DC coupling not advised with Radian. Can with Skybox. Both have generator start and generator protection. So that's the basic comparison there. So, excuse me. The AC coupling advantage is, of course, you can make use of existing hardware, right? You can, the grid tie inverter and everything, you just have to move some of your loads from the main panel to a backup load panel. It's a less disruptive installation. You have little to no time on the roof. It does have a more efficient export. But again, when you're charging the batteries in off-grid mode, it's going to be harder on your batteries. There's no doubt about that. But just for a couple weeks out of the year, it's probably no big deal. With DC coupling, has more benevolent and efficient battery charging. Because we're charging directly from our charge controller, which has like a 97% or higher efficiency rating. So it's going directly from DC to DC. When you're DC coupling, it's more predictable and reliable. With DC coupling, the Radian can use time of use, and we can guarantee that it will never charge from the grid if that's a requirement of some utility program required. So it is more predictable in that regard. You're not going to have any cycling of the grid tie inverter when there's a low load demand. That's one of the performance issues with AC coupling, is that when there's low load demand, the batteries are full, there's no place to put the energy, so that the grid dependent inverter is going to cycle off and on like that. There's nowhere to put the energy. So that's the main thing, is as long as there's energy, and if it's an emergency backup power, there's going to be a place to put the energy. So it's not a common occurrence, but it can happen. And again, it's not a problem. It's just the grid tie inverter is going to cycle a little bit. Okay, and the generator integration is more simple. So that's pretty much what we had here. But before we go to the questions, I just wanted to do a quick little demo. Of our system edge tool. So can you see that okay? Chris, can you, the system edge sizing tool?
Looks great, Mark. Thank you.
You see it? So the first thing you do is you're going to choose an application, energy management, emergency backup. So what this does is, like if you select emergency backup, it's going to use our pure lead batteries because they're not a cycling battery, but they have really long flow life, like up to 15 years. If we click on off-grid, we don't normally recommend off-grid for Skybox, so you're not going to see Skybox as an option. Energy management, you're going to see both inverters up to that. So just make sure you choose your application. And you know, I've seen some competing sizing tools. Like I went onto one site, all they did, they asked me for my zip code and the square footage of my home. And I know how much energy I use and would need. So it really wasn't all that accurate. So anyway, and there's a little, you know, help button here that kind of explains a little bit more about different applications. Power, we were going to have like a choice of a single 120 or a 3-phase, but we don't have any of those options in our system edge packages. But here's the part that's really nice is you come up and you can put in from this drop-down menu, you have all these different loads that you can choose from, okay? And even if you have one that doesn't match, like say, oh, I don't use CFL bulbs anymore, or I'm using LEDs, and geez, they only use 15 watts. And so you can put that in there, but I've got 15 of them. So you can change the quantities, you can change the power, hours per day, days per week. And this is going to give you a much more accurate idea of what the customer's load profile is, because that's what you're sizing storage to. You're sizing your storage to the load, right? So you want to make sure that, you know, and this is for a 24-hour cycle, right? So we want to make sure that, you know, until the sun comes up the next day, we want to make sure that we have enough energy in the batteries to power the loads that they want to have. On there. So you can add a row. Right now, you can put in, like, we have these custom ones at the end. Unfortunately, we don't have a way to edit these. So if you do have a custom load, in a future version, you're going to be able to rename this. But it was kind of complicated, more complicated than you would think, to change that. So we wanted to get the tool out there. But you can add as many of these. You want to just add a row, or you can say, oh yeah, I didn't really want that. You can delete the row also. And so then we hit the calculate button, and it's going to come up with these different options for system edge packages. So you'll notice that it has the total power up here. That's the continuous power. All these loads are hooked on at the same time. What the surge rating is, and like we have one here, like on the microwave, they can really surge. Back in my office here, they even wrote the circuit of this panel and the circuit on the little switch plate there, so you can know which circuit breaker to go reset. So yeah, there's some surge with microwaves. Sometimes with air conditioning. Sometimes air conditioning units, you can put like a soft start or some other way to deal with the surge. But so anyway, so we put surge, we factor in surge. There's a lot of these like competitive transformers and inverters that don't have surge capability to them. And then kWh. So how much energy is this going to use over a 5-hour period? Right? So we're not going to be completely using this much for 24 hours. We're going to use little bits of that, and that's determined by the days per week, hours per day stuff up here. So this is like how much fuel's in the fuel tank. Okay, so then we choose a package. I'm going to just choose this one here. And then I'm going to put in my ambient temperatures. I can choose between Celsius or Fahrenheit. And then I choose modules. We've got like over 200 modules. Now, some of these are kind of dated, but you can always add more if you wanted to do a input custom. So here you would just put in the model name, power, VOC, you know, the basic specs of the module. And then when you put that in, then it's going to show up for them to just calculate with that module. So I'm just going to go choose one of these other ones here. And calculate with that module. And it's going to tell me modules per string and then 4 strings. So this is the maximum array size. So that's like you can have up to 7,000 watts with the FN100, and then it tells you your maximum VOC and BMP based on the temperature that you entered up here. And then when you're all done, you hit print results, and then it shows you, you know, printout of everything you selected. Here's the loads that you did. Here's what you're sizing to, the total kVA, the surge kVA, and the kWh. Here's the system mesh package. Here's the temperatures you used in the calculations, solar module, and how many you're going to need. So here you need 20 of the Canadian Solar 340, and this system mesh package. And you print this out and give it to your customer, and should there be any problems later, say, well, Mr. Customer, this is what we sized your system to. This is, you know, what we agreed on. You didn't, that hot tub that you added is not up on this list. So it's a good way to, for you to have a record of what your proposal is. Okay, and then you can just print that out. So I just wanted to touch on that real quick. It's a really nice tool. This is not yet available. It's going to be on our website. Could be as soon as next week. And our friends at Soligent are going to let you know when that becomes available. So that's all I had. If we wanted to open up to some questions.